Imagine every movement you make is recorded. Every thought you express to others is recorded. In the form of data stored somewhere thousands of miles away in a data center. Your phone is one of your most important part of your life. Without it you feel incapable of a lot of things. You wake up in the morning and the first thing most of us do is to hold our phone, go through emails or maybe surfing social media. You are immediately in contact with artificial intelligence and you do not even realize it. Most of us are being influenced by artificial intelligence daily and a large part of our life depends on it, but also most of us have no idea apart from the instant dopamine rush we get with the help of artificial intelligence. It is addictive. It is powerful. It is in control of our lives. TikTok, Instagram, YouTube, Netflix. The big thing behind these companies can also be considered the algorithms they use to make the user experience as seamless as possible. TikTok's algorithm, for example. You just open the app and scroll through some reels. And the algorithm already has known you very well. It shows you reels based on what you like. It tracks the time you spend on watching a reel and then based on the tags of the reel and other metrics matches it with you and that reel appears on your feed. It takes some seconds to hook you up and after that you are not in control of your time. YouTube and Instagram also work in a similar manner. The first question which comes to my mind is that, why? And the simple answer is time or attention. See what Mr. Beast said about the YouTube algorithm.
I think YouTube wants, to me, I think YouTube just wants people to click on a video and watch it, right? I mean, that's how they get their ad revenue, that's how they keep, viewers happy and stuff like that.
And how do they make it possible? Machine learning. Everything is recorded. Two things are needed to fuel artificial intelligence. The first one is data. The total amount of data created, captured, copied and consumed in the world was 33 zettabytes, equivalent of 33 trillion gigabytes in 2018. In 2022 that has grown to 94 zettabytes. Every day we are producing dump loads of data at every corner of our planet. You might be asking that. What do we do with so much data? Is it useful? Yes. Think of data as a container which contains information. Now all this information can be used as raw material for educating machines by the help of artificial intelligence. We can use this information to make machine learning classifiers. If you are thinking about what a classifier is. For example, image recognition is usually done with the help of a machine learning classifier. In simple words, this is an image of a cat. And this is an image of a dog. And we want our algorithm to tell us which one is cat and which one is a dog. What we can do is that we can take a lot of images of cats. And we take a lot of images of dogs. Now we want to differentiate between a cat and a dog, so we extract features from the pictures of cats and from pictures of dogs. For example, the size body of cats and dogs differ from each other. So we can put all the images of cats and dogs into the classifier and program that usually cats have a size of blah blah and dogs have a size of blah blah. Then when we ask the algorithm to tell us if this is a cat or a dog, the algorithm will compare the sizes and the form based on the information it has collected from the pictures we provided before. It will differentiate between these pictures and tell us that this looks like a cat.
We know that AI and machine learning are inextricably linked, but how? Artificial intelligence refers to the science of training machines to perform human tasks. Defined sometime during the 90s, this evolving technology aims to mimic the way our human brains interact and gather information from the world around us. Where AI is the broader science, machine learning refers to the specific subset of AI that trains a machine how to learn. By looking for patterns and drawing conclusions on data, machine learning models can artificially establish a point of view. So instead of writing code that tells the machine exactly how to think, we can now simply ask the right questions and let the computer calculate. Once your machine learning algorithm understands all the available data, it's able to apply that knowledge to new sets of data, increasing accuracy and performance. Deep learning. As a subset of machine learning, this AI technology changes how we think about the relationship between problem solving and analytics. Instead of training the computer how to think, deep learning lets the data train the computer, leading to predictive models that become stronger with each set of data it's fed. Most commonly used in features using speech recognition or image identification today, deep learning doesn't need us to facilitate how it organizes data. For example, if a deep learning machine was designed to tell the difference between a rock and a baseball, the machine would use neural networks to identify the stitching characteristic as a sign it's a baseball, as opposed to being programmed to look for that detail. Neural networks. The most effective way to explain neural networks is to think of them as a human brain. Instead of neurons working together, they use interconnected nodes to identify correlations within raw data. Located between an input layer and output layer, these nodes form a network of connections that interact with one another to calculate an output. The more information the network receives, the deeper the computational power becomes, similar to the way a human brain develops. Computer vision. Upon the introduction of digital cameras and images, this AI subfield became an inevitability. Computer vision refers to the ability to accurately identify and process objects in the visual world. The computer can acquire the image in several ways, through real-time pictures or video, most commonly seen in facial recognition software. The computer then uses deep learning models to process properties within the image, based on a robust collection of pre-labeled images in its memory. From there, computer vision can identify the object. Natural language processing. Like computer vision, natural language processing, NLP, explores the auditory side of AI technology. NLP allows computers to process, understand and produce human language, bridging the gap between human communication and machine understanding. As a pioneer technology in the world of computation,